Okay, so prime factorization is a way to break down a number into its prime numbers, a way to break down composite numbers until smaller forms, okay? So whenever I say prime factorization, I want you to think about breaking numbers down. Breaking numbers down, okay? We're going to do an example here with 24. So someone raise your hand and give me a pair of factors for 24. Daniela?
6 times 4.
6 times 4. And those numbers are both composite numbers, so we can still break them down further. Tanaya, can you give me a factor pair for 4?
8 times 3.
For 4?
Oh, for 4. 2 times 2.
2 times 2. Okay? And once you get to a prime number, what do we do?
Circle and stop.
Circle and stop, because we don't have to keep going on those anymore. Okay? Now let's break down 6. Samantha? 3 and 2. And again, 3 and 2 are both what kind of numbers? Prime numbers. And what do we do to prime numbers?
Circle and stop.
Circle and stop. Okay? Once you have your numbers broken down to where you can't, everything is circled, you no longer have to find factors, then go ahead and write 2 times 2 times 2 times 3. Okay? So this is our prime factorization for 24. That is the prime factorization for 24. All right, and this entire thing is called a factor tree. So somewhere on here, maybe I should do it with a green. That would be interesting. This is a factor tree. I'm going to put on here factor tree. Sometimes what you're going to see is you might see the factor tree without that first number filled in. Okay? So let's do something. I'm going to say, put a box here. There's going to be a number that goes into there. I'll show you 2 ways that you can figure this number out. Okay? Now the first way you could figure this out would be to take the top level and then just multiply those together. So 6 times 6 is what? 36. Okay. I'm just going to put it here to the side. But again, we know that this is a factor tree, and so we could put the numbers here. 2 times 2 times 3 times 3. And then anytime that you want to find out the number that is being represented by the prime factorization, then just do what it says, multiply. Okay? So what's 2 times 2? 4. Okay, well, bring my multiplication down. Then 4 times 3? 12. Bring my multiplication down. Bring my 3 down. 12 times 3?
36.
So then my answer for here at the top of the tree would be 36. Okay, which is what we got here. So most of the time, if you just look at those first 2 numbers, you'll be able to determine what number goes in the box. You could also always use the prime factorization and then multiply it out, and you should have what goes into the box. Okay? Many times also, just to trick you, I think, you might see this. 2 times 2 times 3 times 3 times 1. Can this be prime factorization?
No.
Why not?
What is special?
1 is special. So make sure you write that, and then you're going to put a big X over that 1. I'm going to put a box around the 1. I'm going to put a big X over it. That is incorrect. 1 is special. It's wrong because 1 is special. It is not prime. It is not composite. Okay? 1 is special. What about this? What's wrong with that one?
There's three and there's that's a 4 is not prime.
Charlie, what did you say?
4 is not prime.
4 is not prime. That's what makes this wrong. So 4 is not prime. I'm going to circle that, put a box around it. And this is wrong
Because it's composite.
because 4 is composite. Composite. Okay? So even though this may equal a number, 4 is not composite, and so that is not prime factorization. When you're looking at prime factorization, each of your numbers have to be composite numbers because that means that they're fully broken down. Okay?